Hey everybody, welcome to the 6.4 video. This is what you should be watching while I am giving the ACT to our juniors. Make sure that you have the notes, which is the front side of this, and the assignment, which is on the back side, done by the time you come back to me on Thursday. Okay. Also, make sure that you are listening to this video. Okay. Realize that you probably can't hear that if you don't have it on, so let's go ahead and do this. Turn your sound on, guys. Make sure you have your sound on because this isn't going to make much sense if it doesn't. Today's lesson is not very difficult, but it doesn't make much sense if you're not listening in. So, what we are learning today is called special polynomial multiplication. All of the examples today are polynomials that have a special pattern when they're multiplied together. And these can be used as shortcuts, or you can just multiply them as normal. What we're going to do is multiply them normally so that we can find the pattern. And you'll realize that there is a place at the bottom of each side to write the pattern. Okay? So we've got two patterns here today. The first one is called conjugates. And you might be like, what in the world is a conjugate? Well, this is what happens when you're multiplying two things. See how these are almost the same, but the sign is different? Those are called conjugates. And then down here, you're multiplying by the same thing but opposite sign. Those are called conjugates. Okay? So something special happens when you multiply these together. I'm going to use the box method. Feel free to do it the other way if you would like. The box method is just a little bit harder to follow along with if I don't write it out. I mean, I don't really feel like we needed to take the time to write it both ways anymore. Okay, so I'm going to take 2x plus 3 times 2x minus 3. So 2x plus 3 goes on one part of my box, one side of my box, and 2x minus 3 goes on the other side. And then you just need to multiply these two things together to get the middle. So 2 times 2 is 4. X times x is x squared. So you have 4x squared. Then we're going to do this one next, which is 2x times negative 3. That's negative 6x. And then 2x times 3 is 6x. And lastly, negative 3 times 3 is negative 9. Then, after you've drawn your box and filled it in, always make sure that these two have the same exponent, because they should. And we're going to add those together. Here's what happens. Negative 6x plus 6x is 0. So you just have 4x squared and minus 9. You don't write the x's in the middle because there's 0 of them left. They've disappeared. Okay, and I'm going to do this one down here as well. Similar idea, same thing in both parentheses, except for one has a plus and one has a minus. So I'm going to draw my box. On one side, I'm going to write x minus 8. And on one side, I'm going to write x plus 8. And then we're going to multiply to get the middle pieces. X times x is x squared. X times 8 is 8x. X times negative 8 is negative 8x. And 8 times negative 8 is negative 64. And I will give you a second to make sure you have all that written down. I know the box takes a second for some of us to draw. Then, in my diagonal, my x's add together. But hey, look at that. 8x plus negative 8x is 0 again. So I just have x squared and negative 64. Okay? So here is the pattern that we should start seeing here. And that is that the middle terms, or the middle parts, cancel. And they are canceling because these were the same thing, but one was a plus and one was a minus. That's why these have to be the same thing, but one is a plus, one is a minus. Okay? And then what you are left with is the first term squared minus the second term squared. Here's what I mean by that. X squared is x squared minus 8 squared is 64. Okay, or on the top, 2x squared. 2 squared is 4, x squared is x squared. So you have to square both the number and the variable if there's both. And then 3 squared is 9. These will always be minuses. That's why I put a minus right here in the pattern. Now let's try the squared binomial. Squared refers to this. Binomial refers to the fact that there are two terms. So 2x and 5, there's two terms. Now, when you multiply 2x plus 5, when you want to square 2x plus 5, that means you're multiplying it by itself. So when I draw my table, I need to put 2x plus 5 on both sides. And then here in the middle, I need to multiply. 2x times 2x. Well, 2 times 2 is 4. X times x is x squared. 2x times 5 is 10x. 2x times 5 is 10x. And 5 times 5 is 25. Pause the video if you need to write that one down. I'm going to go ahead and add the middle parts. Careful though, they're both positive. So that makes 20x in the middle. Okay, now let's do one with 7x minus 2. Same idea though. Draw your box with 7x minus 2 on both sides. Okay, 7x times 7x is 49x squared. 7x times negative 2 is negative 14x. 7x times negative 2 is negative 14x. And negative 2 times negative 2 is 4. Then you add these two in the middle together. Negative 14 and negative 14 makes negative 28. And there's your answer. Here's the pattern here. Nothing cancels out, but it's going to be the first one squared, and then 2 times the first times the second. So 7 times 2 is 14, times 2 is 28. And then the second one squared. So it's kind of like the first pattern, but you have this middle piece. And the reason why I'm not putting a plus or a minus right here is because 7 times negative 2 is negative 14, times 2 is negative 28. But 2 times 5 was 10, times 2 is positive 20. So this symbol just matches with whichever one is up there.